Welcome to the Citizen Science App for Kids project for CS467 Capstone. Our mission for this project is to create an accessible and kid-friendly platform that allows teachers to design meaningful scientific activities for their students to learn and grow. Our team consists of Lexi, Samantha, Olga, and myself. We built a mobile application for students to use in and outside of the classroom to collect, edit, and submit observations. We also built a supporting dashboard for teachers to create custom projects, view observation submissions, and analyze the results with their students. This application is kid friendly. It delivers only pertinent project information to students when they need to see it. It allows teachers to create fully customizable projects and visualize their students' observations, view uh, via beautifully rendered charts. The primary technologies we have utilized are Flutter for the mobile application and the MERN stack for the web application and both applications' backends. We've used the Google Cloud platform for hosting and user management. Here's a look at the teacher dashboard. On the left, we have the Google OAuth 2.0 login functionality. On the right, we have a view of the teacher's projects page. Next, we have the form that the teachers use to create a new project. On the right, the project results page where teachers can view the details of a student submitted observations. Here we have the student flow from accessing a project using an easy to remember class code, viewing the project description and instructions, creating an observation, viewing that newly created observation, and then editing or deleting their observations.
Hello everyone, my name is Lexi and I was responsible for developing the mobile field app for students. So basically I just built all the main screens in Flutter, which includes the class code page, project page, observation list, add and edit observation screens. And because I did the mobile app, I also connected the app to the back-end APIs, and then in the end I also helped deploy the web and mobile apps. In terms of major technologies used and why, mainly I just used Flutter with Dart for a cross-platform app with a kid-friendly UI. Xcode and iOS Simulator were my best friends during this project in terms of testing, and just for deployment I used Docker, Google Cloud Run, and TestFlight. In terms of development, I started by reviewing our requirements and user stories from our requirements document, and then I set up the Flutter environment, and I designed kid-friendly mockups with Figma, and once all of those were agreed on, I built the main app pages and connected them to the back end. Once it was all said and done, I finally tested, debugged, and polished the UI. In terms of original and what was deviated, there were no significant changes in general, but originally students were just going to use a class code, but then we ran into the issue that maybe teachers couldn't distinguish them. So I offered this explore design here. What if we use username and passwords, but that would have been too complicated for younger students. So in the end, we use Google authentication, which is just because it's simple and familiar, and it also gives a student a unique identity. So, in terms of challenges, I faced a few challenges, but I guess the biggest one was the handling multiple observation field types like text, numbers, and dates and checkboxes were tricky, but I just had to go back and map each field type to the correct Flutter input widget, and I tested it locally until integration worked. Deployment was the hardest, until I had to go back to the logs, and then I saw that the container wouldn't start due to the wrong CPU architecture. So once I saw that and I rebuilt the image with the correct platform, the deployment finally succeeded. So overall, from this project, I learned about backend integration, how important teamwork is through check-ins, and deployment, and overall it was a fantastic learning experience that strengthened my mobile development skills, and it was really fun.
Okay, so the parts of the project that I worked on was the results page where teachers could view student observations. They also could view graph visualizations. I also created the CSV export feature, and I developed the student and teacher login system using Google authentication. What were the major technologies used and why? I used React for the front end, Node for the back end. Both of those were used because the team had the most experience with them. I then used Chart.js for my interactive charts and Google Authentication for my login method. These were used just to make things simple and easy and to integrate. What were the stages in my development? First, I set up my database structure and got approval from the team. I then set up the login system using Google Authentication. Then I developed the results page, linked the observations to that results page, implemented the charts, added CSV export functionality, and then tested the entire data flow. And then lastly, cleaned up the UI. What was the original plan and what were the deviations? So at first, students were not going to be required to log in. They were just going to submit their class code, get access to the project, and go from there. However, during development, we realized that students needed a way to view all of their past submissions. So we decided to add student Google authentication to do this. What were the challenges you faced? I had some trouble getting my charts to update correctly, especially because the mobile app was sending strings instead of numbers. And then I had some trouble getting Google authentication to work for both teachers and students since they had two different roles. How did you overcome them? I worked with Lexi, who created our mobile app, and ensured that any numeric observations were coming to me as a number, not a string. And I used Google authentication documentation to be able to debug and figure out how to set it up properly. What did you learn from this process and project? I learned how to implement authentication for multiple user types in the same system and how to transform real student observations into visualizations. And lastly, I learned how to better collaborate with the team and make sure all our parts are working together.
Hi, my name is Olga, and for this project, I designed and developed teacher or admin main page and create project page. I built the project list view, implemented the key project actions, and created the full project creation workflow with both required and customizable fields. I used React for the UI, Node.js for the backend logic, and MongoDB for its flexible schema to store project data. I started by designing the teacher dashboard layout, then built the project list and connected it with Samantha's database work. I also implemented UI for the create, delete, activate, and deactivate actions, making sure everything is aligned with Keegan's backend logic. After that, I developed the full create project page and tested the entire flow from login to project creation and management to ensure everything worked smoothly. The original plan stayed mostly the same with only minor adjustments. We spent extra time finalizing the login approach, and the create project page evolved from simple text fields into a hybrid design with required and custom field options. One challenge I was staying flexible with the feedback, but it was quite hard for me to take it on. But solid communication within the team made adapting much easier. I also had issues with integrating login into admin page, but with steady support from the team and Samantha as she worked on the login, we worked through those challenges and also made the needed updates to run it smoothly. Um, Overall, I learned how to design user friendly, flexible pages, gained more hands on experience with React, Node.js, and MongoDB, also improved my teamwork, communication, and ability to use feedback effectively.
My part or parts of this project, I originally wrote the requirements into a specification document for the backend API. This includes HTTP methods, routes, request, and response body examples, along with a description of the intended effect. This was to coordinate our efforts while working on the front end and back end asynchronously. I wrote the basic CRUD manipulations for projects and observations, deactivate and reactivate project functionality, and the class code login for students. I also worked as team leader at the meetings and code reviewed the pull requests that were not my own. The primary technologies I used were Node.js and Express.js to build the backend code. I also used Atlas MongoDB to update the database schema and work with the cluster. The steps of the development, we decided on the requirements based on group meetings. I then compiled our design decisions into a agile scrum type whiteboard for our API spec document in order to coordinate the group's efforts. Next, I started by building each endpoint by sketching out the function on paper, writing the code, and then finally writing postman tests to verify the endpoints worked as expected. The original plan was for us to each work on the back end and front end, so we each got more experience with a variety of tasks. Due to time constraints, I ended up working mostly on the back end and only cleaning up some small aspects of the front end in the final stages. Challenges we faced, we changed directions on the login for students. This was overcome by Samantha and I splitting the student login and the class code login and each tackling a portion of it. I learned that it would have been helpful to have smaller and more concrete tasks that we execute every day or multiple times a week to maintain clarity and adherence to our specification. It became very easy for me to write a lot of code and make a large pull request, but that doesn't necessarily lend itself to high quality software development. We are very excited to continue work on this application to make it open source, more maintainable, and to add features that we're very excited about. Some of these features include the ability for teachers to edit existing projects, allowing students to add pictures to their observations, geotagging those pictures, utilizing an LLM API to provide students with the latest tools and analyze those pictures, and also enabling offline work. In conclusion, our platform provides teachers and students with accessible tools to learn, grow, and reach their science goals in and outside of the classroom.
Okay, so this is our admin login or sign up page. They will click here to log in using Google. If they are already in our database, once Google sends back the information, they will move on to the next page. If they are not already in our database, then our code will automatically sign them up. So no further action is needed from the teacher. We'll log in. And as you can see, it brings us to the next page.
After logging in, teacher will see the main page, which is right here. Teacher dashboard displays list of all existing projects. There is currently 2. Add new project button allows teacher to start new project easily, and it will be immediately added at the top of the page, so they're gonna go down. Each project shows unique class code next to the project name, which students use to join the project. For every project, teacher can deactivate if it's no longer needed or there is a break for easier management, and also activate it back if the students are back. Teacher can also delete the project, delete button right here. Okay, so it was smooth. A results button lets teacher to see all of the students' submissions and data, and also download it as a file. When teacher clicks add new project, create project opens, the page requires 2 mandatory fields, title and instructions. Let me add title and then instructions. Teacher can add flexible custom fields such as text, number, multiple choice, date to structure how students will submit their observation. After, let's do some fields. So number and color. After filling in the details, clicking create project generates project. The system automatically assigns the unique class access code to the new project. The newly created project and its code can be visible on the main page, and it's super easy for the navigation.
Okay, so this is our results page that each project will get. Up at the top, we'll have the project description and title, and then any fields that the teacher added that were numeric will then populate here with their average, their min, their max, and their count. And we have dynamic charts for each of those numeric fields as well, based on the observations that are already submitted. Down here, you can see all the observations that have been submitted for this particular project, and the teacher can click download CSV and be able to download a CSV file. This is our mobile app where the student can sign in using Google. So they would click sign in with Google. A pop-up will pop up from Google to sign in. And it will bring them to the class code page.
Here we see our class code login, creating a new observation, and editing that observation.